Hey everyone, today we're going to be looking at adding and subtracting polynomials, and this is meant to be at the very start of an algebra section. So we're going to do things on a very basic level. And to start with, we've got these algebra tiles. Now these are meant to help you add things together, and if they don't help you, of course, you can just totally disregard it. So notice here that for this algebra tile, this says three things that say x. The long bars are x, so x plus x plus x. That's the 3x over there. And then the smaller squares, those stand for 1. So you've got a 1 here and a 1 here, so this is 2. And that's this first grouping. And then this second grouping here, this is 1x. And you can see there's an x here. And this is 1, 2, 3, 4, 5 negative tiles. So this is either minus 5 or plus negative 5, depending on how you want to look at it. Now here in step 2, we're going to take this tile and we're going to put it over here. So basically we're grouping everything together. So we've got 1, 2, 3, 4 x tiles. So this looks like 4x to me, and then plus, and then this is 2 positive tiles, so plus 2, and then this is 2 negative tiles, so 2 negative tiles, and then 3 more negative tiles. And now that I have that added together, here's what I notice. I notice that this over here, the positive tiles and the negative tiles, they create 0 pairs. Much like we do algebraically, these over here are going to form a zeroed pair. So when they form a 0 pair, we're going to get a 4x plus 0 minus 3, which is just 4x minus 3. And you can see that here. You've got 1, 2, 3, 4, 4x, and then 1, 2, 3 negative tiles, so minus 3. And that's how we add things with algebra tiles. It's a handy visual to have, but I understand not everybody is going to be a fan of that. So, just whichever works best for you is what I'm saying you should do. Okay, there is more algebra tile work over here. Of course, we can kind of add all this together. This larger square is an x squared. So this is an x squared. We've got 1, 2, and then we've got a negative tile. So this is 2 x's and then a negative x. And then we've got 1, 2, 3 positive tiles. Now, I notice that these can form a 0 pair. So when they formed a 0 pair, what's left is an x squared plus an x tile plus those 3 unit tiles. So more of those. And that brings us to use those methods to kind of help things along here. So let's do a couple of these. We notice that there is a plus here. And what I like to say is when there is a plus sign, that means you can take everything out of the parentheses with no consequences at all. Just rewrite everything without parentheses. And then we're going to group things together. You've got the x squared here and the 2x squared there. I think I'll highlight those with yellow. So x squared and a 2x squared, that's 3x squares. And then we'll take the next color, which would be for the long tiles. That's a 2x and a minus 2x. And actually, that forms a 0 pair, doesn't it? So that's a plus 0. And then we'll take a look at the unit tiles. We've got a minus 1 and a plus 1. Again, that is a 0 pair. So when we're finished, we just get 3x squared. So maybe a little bit unsatisfying that, there's a lot of zeros there, or maybe the opposite. Maybe that does feel satisfying. I don't know. Let's look at D. You've got a minus sign now. So when you see a minus sign in between two parenthesis units, you got to play with some special rules. And the special rules are going to be this. That first unit, that first parenthesis, we're just going to leave it alone. But then we're going to change this negative sign into a positive sign. Now when we do that, the consequence of that is everything inside the parenthesis is going to change sign. So this was a positive x squared. Now we're going to make it a negative x squared. And this was minus 2x. So now we're going to make it plus 2x. And this is a plus 4 here. So we're going to make that a minus 4. And now that we have a plus sign between two parentheses, like I said earlier, you're free to take the parentheses away and just make them what they are. So you got 2x, a minus 3x, a plus a minus x squared, a plus 2x, and a minus 4. Now, there's this thing called standard form, and in standard form we look for the highest power and put that first. So I'm scanning. This is a 2x, this is a 3. This has a square power. That's the highest power I've found so far, and there are no other powers here. So I'm going to put that square power first. And don't forget the sign in front of the monomial, we're going to call those monomials now, it stays with that variable piece, that monomial. So keep the sign in front. Okay, let's take a look at the next set of terms here. I'll put a plus sign. And then I'm going to look for the next powered term, which seems to be x to the first power. So we've got a 2x there and a plus 2x there. How many does that make? 2 and 2. Last time I checked was 4. So that's 4x. Put a plus sign. And then let's take a look at the rest of the monomials, the constant terms. I've got a minus 3 and a minus 4. That makes a minus 7. Now I've written it in a way that's kind of awkward over here with a plus a minus 7. So we can rewrite that. Minus x squared plus 4x minus 7. So that's kind of going to be the level of difficulty of the work we do today. So if everything is good, if you understand that, then I think you're good to go. But otherwise, we're going to take a look at some vocabulary units here. So here's our vocabulary. A monomial is a single algebraic unit consisting of a constant and or a variable, and they are multiplied. So what I'm saying is 9 minus x, that's not a monomial, because even though it consists of a constant and a variable, they're being subtracted there. So this right here, not a monomial. Here are some examples of monomials. 5, negative 9x, 12xy squared. Everything there is being multiplied, so those are monomials. Next, we have the degree of the monomial, and that's just going to be the highest power of the variable. So if I look at that, this is degree 2. This one over here is degree 1. This one doesn't even have a variable, so that's actually degree 0. No variable means degree 0. It's a weird thing. Polynomials are one or more monomials added together. So let's take a look at the examples. We've got 4x squared minus 6y. Those are two monomials subtracted. And then we've got 100 minus 13x plus 9x to the 5th power. That's 3 monomials added and subtracted together. We have special names for those. We've got binomial for 2, you might think binomial like a bicycle. You know, a bicycle has 2 wheels, so bi equals 2. And then over here, the next one we have is a trinomial. That's a polynomial with 3 monomials. Again, tri equals 3. It's good to have that reinforcement of the word roots here. So even if you don't know what it means, if you saw the word tri in it, then you know that has something to do with the number 3. The degree of the polynomial is the highest power. So if I take a look at this trinomial over here, this is a 2nd degree trinomial because the highest power is 2. Standard form. A polynomial is in standard form if the powers are decreasing and each term is written with the constant first, followed by the variables, followed by the radicals. So it's a very strict ordering of the way things are. It just makes algebra a lot easier if we write everything the same way. So I encourage you, whenever possible, keep things in standard form. It's easier to think about. So here's standard form. We've got x to the 5th minus 9x cubed plus 8x. The powers are decreasing. Notice we've got 5, 3, and then there's no power here, but there's still a variable, so that's to the 1st power. And then they're all written with the constant in front. No constant in that case, constant in this case, constant in this case, and then the variable after the constant. Now in this one we have decreasing power, and you can kind of tell that because this does have variables in it, but the 2nd term here, no variables in it. So decreasing order. Here we've got, what is this, the constant first. What color was I using for constants? Blue? Okay, so constant. And then variables. Variables we were saying were green. And then the roots come after that, the radicals. So let's highlight that radical there. That radical always comes last. Okay. And then the last thing that we're going to do is a lead coefficient. That's just going to be whatever constant is in front of the lead term, or the highest powered term. If your polynomial is written in standard form, then that lead coefficient is going to be the very first term of the polynomial. So that's all that fun. We're going to be using this vocabulary for the next section. So you might want to get yourself acquainted with the vocabulary. And this is kind of a review of what we just talked about. You can go ahead and look at that. Notice we've got lead coefficient, degree over here, 3, x squared, x to the 1st power, 12. We call that a constant term, but we've been calling it the constant term all year long, so that's not new to you. So let's go ahead and find the degree of the monomial. Here's a monomial. There's no power, so the power is 1. So this degree is equal to 1. Easy, right? Over here, the highest power is 2, so this degree is 2. Over here, the highest power is 3, so this degree is 3. And this one has no variable at all, so this has a degree of 0. Next, we're going to write the polynomial in standard form. Number 9, let's see, I've got a 3x to the 2nd power is the highest power. So we'll put that first, plus 3x squared. The next powered term is going to be, the next highest powered term is going to be that x. Now that x doesn't have a sign in front of it, but we're trained that if there's no sign in front of a variable, it actually comes with a plus sign. So I don't know why I wrote a 2, plus x. And then the very last one here is plus 5. Now optionally, you can write this without the plus sign in the front. Most people think that that plus sign is kind of awkward. So just 3x squared plus x plus 5. Let's get to number 10. In standard form, the variable should be in front of the root. So that's y root 5. Okay, so now we're going to start adding things together. Let's do 13. And I notice there's a plus sign right in the middle there. So I'm going to just free all of the monomials. That's right. Free them. No longer inside those parentheses. And we're going to look for the highest powered variable. And it looks like it's the x to the first power. There's a 4x to the first power. There's a 6x to the first power. And we're going to add those together. Okay, so 4x and 6x, that's, minus 4x plus 6x. That's the same thing as 6 minus 4. So that gives me a plus 2x. Plus 2x. Plus. Now the next is a constant term, so the only thing left. We've got a plus 4 and a minus 14. Now, you can grab your calculator if you need to, but I think that 14 minus 9 is 5. So I'll put a 5, but the 14's bigger and the 14's negative, so it's actually minus 5. And now we're going to rewrite it so it's less awkward. We don't need the plus sign in front of the 2x. And plus a minus 5, that's the same thing as minus 5. So there we go. There's our sum. Number 16. Again, we're going to free all the monomials because there is a plus sign in front of or in between the two parentheses. And then we're going to scan and look for the highest powered term, and it looks like it's t to the third power. So let's go ahead and look for all the t to the third powers, being careful to also preserve the sign in front of the coefficient. So what do we have? We've got plus 3 and a minus 2. That's the same thing as 3 minus 2, and 3 minus 2 is 1. A positive 1 t to the third power. Plus. Now we're going to go in descending order, so the next thing should be a square term, second power. So there we got a t squared. I'll put a plus sign in front of that. And then we've got a plus 2t squared over here. Make sure you take that sign with the monomial. And what does that say to me? That says plus t plus 2t. I'm sorry, t squared plus 2t squared. They're both positive, so we'll just add them together. That's 3t squared. A plus 3t squared, really. Plus. Now our next term should be the first ordered term. And here's our first ordered term. I think that's the only one that we have. So that doesn't get to combine. It's going to be all by itself over here. That's going to be a 7t. And the very last one that we have here, poor guy, that's just the minus 3. So plus a minus 3. Okay, let's write this but less awkward, okay? Plus 1t cubed, that's just t cubed. Plus a positive 3t squared, that's just plus 3t squared. Plus a positive 7t, that's just plus 7t. And plus a negative 3, that's just the same thing as minus 3. So there we go. We're in standard form too, because we did this the way that you probably should be doing this all the time. Always looking to put things in standard form. It also kind of helps keep your head on straight, because you'll know where to go first and what to do second. We're going to go to number 18 now. And the first thing I'm going to have to do, I see there's a minus sign in the middle here. So I'm going to use my special rules, change that to a plus sign, and then change the sign of everything inside the second parenthesis. So this will change into a plus sign. This was positive 7, now it's going to be negative 7. This was plus 6, now it's going to be minus 6. And now that I have a plus sign in between the parentheses, I can free all the monomials. Minus 7h minus 6. And then we're going to start looking for the monomials. The highest powered term, the only variable I see is h, and the only h's I see are in the first power. So I'm going to combine those two together. Always take the sign in front. Always take the sign in front. Minus 7 and minus 5. Those are the same sign, so we're going to add them. That's 12h, and it's negative. Plus. Now the only terms left are constant, so we'll combine those together. So you've got a minus 2 and a minus 6. That is a minus 8. And then we'll write this again, but less awkward. Minus 12h minus 8. Okay. And, you know, that kind of feels a little weird because you have that minus sign in front. But yeah, that's correct. That's what we got to do. So we're moving on to 19 now. And I see again a negative sign in between the parentheses. So I gotta have to play by my special rules. Minus x squared minus 5, that's fine. But everything inside the parenthesis is gonna change signs. So this minus is gonna become a plus. This minus here is gonna become a plus. The minus in front of the x is gonna become a plus. And the minus in front of the 8 is going to become a plus. And now that I have a plus sign in between the two parentheses, I can free the monomials. Plus x plus 8. And now we'll look for the highest powered term. A quick scan shows me that we've got a second degree power. So I think that's going to go first. Second degree power. So we've got minus x squared plus 3x squared. That's the same thing as 3x squared minus x squared. That's 2x squared. Positive, of course. Plus. Now the next highest powered term is the first degree, first power term. To the first power, that's that x over there. And there's nothing to combine it with, so we'll just rewrite it again, plus x. Plus. Now the last things that we've got here are the constants. We've got a minus 5 and a plus 8. Remember, constant means it has no variable attached to it. Minus 5 plus 8, that's the same thing as plus 8 minus 5, which is positive 3. And now we write it just less awkward. 2x squared plus x and plus 3. And that's our algebra journal today. Hopefully these little tips will help you add your monomials together, or will add your polynomials together. And we'll see you for the next video.